Class. So in today's lecture, I want to talk to you about two different topics. The first topic is about return functions, which will be an extension of what we talked about last class about void functions. And then I also want to talk to you about some more properties of sprites that are unique to sprites and will be helpful or useful for some of the apps we're going to build with this lecture today. So let's go ahead and get started. So the first topic I want to talk about is return functions. Last class we talked about functions in a general sense and how functions are built to perform a singular task. So we create or define a function that performs a single task for our application, and then we can call that function multiple times throughout our app in different event handlers or even on different screens. The purpose of writing a function is that it allows us to consolidate a lot of our blocks and make our code, our blocks, more reusable, more readable, and more organized. We talked about how there are two main kinds of functions. The one we discussed last class was called a void function. And a void function, as you might recall, is a function that performs its task and that's it. It just goes, it does its task, and then that's it. The other kind of function is the one we're talking about today, which is a return function. A return function is very similar to a void function. It has a lot of the same qualities as a void function, insofar as it also performs a single task. It helps keep our blocks and our code more organized and concise. But return functions have the added operation of once their task is complete, then outputting or returning some piece of information. We talked about an example last class where you might write a function whose task is to sum two numbers, to add two numbers together. And we talked about if we were going to write that function as a void function, I would write the function so it just adds the two numbers together and that's it. Whereas if I were going to write that function as a return function, I would write a function that adds two numbers together, the same as the void function does, but then I would add on the extra piece where it then returns the result of that task. So in this case, it would return maybe the sum of those two numbers. It would kind of be like if I was asking you to do this calculation for me, and if you were a void function, you would just sum the numbers and that's it. Whereas if you were a return function, you would sum the two numbers and then maybe write the sum on a piece of paper and give it back to me. And that piece of paper, that value that you're giving back to me, is a return. So let's take a look at how you can write return functions in Thunkable. So in order to create or define a return function in Thunkable, we're again going to go to the functions drawer, which is one of the default drawers that you get in any Thunkable app. It doesn't have anything to do with the canvas or with games. It's there in every single app. And the second block here in this drawer says to do something and return. This is really similar to the block above it, which is the one that we would use to define a void function, except for you'll see that it has that word and return, and it has this little block inside of it that says return with a little notch on the side. A lot of the things about this block are similar to the void function block. You can still rename the function to whatever you desire it to be in the section that says do something to make it more clear what your function's purpose is. We also talked last class about how you can add inputs to a function. You can also add inputs to a return function using the little plus icon that's on the block, and you can add as few or as many inputs as you would like. The only difference is that this block will, when you're defining a return function, it will always contain this little block that says return inside of it. That is the return block. You will always have only one of them in a return function, and it will also always be the last block in the function. You can kind of tell by the shape of the block that it has to be last and the only one because the bottom of the block doesn't leave any space for another block to be snapped underneath it because it's a flat block. And you'll see that there's a little notch to the right of it. This is where you will specify what the returned value is. So in the example I was talking about making a function that sums two numbers, the number that you would write down on a piece of paper and give to me, that would be theoretically what would go in the notch next to this return block. Whereas the actual operation of doing the addition would come before that block. Okay. So the question is, why would you want to use a return function over a void function? The truth is that a lot of functions or things that you are operations that you would want to turn into functions could be made into both void or return functions. It kind of just depends on how you want to design your app. And you kind of get to choose. If you when you are designing a function for your app, if you're telling yourself that this function needs to come up with some sort of like answer or solution, or it has some sort of result of the task that it completes, then that might lend you to thinking that this function might be best as a return function. You could probably still write that function as a void function, but there might be circumstances in which it makes a little more sense to use a return function. To illustrate this, I actually want to go back to an app that we had spoke about last class, which is this points app. So you might recall in this app, I have just 3 components on this screen. I have a big label that says the word points and then a numerical value following it. And then I have 2 buttons on the screen, a green one that says add points and a red one that says subtract points. Here on the left-hand side, you can see all of the code for this app, and let's go through it real quick. So I have initialized an app variable called points. I've initialized that variable to 0, and this is going to be representative of how many points have been accumulated throughout the use of this app. Inside of these 2 event handlers, I have similar code. In the add points button, click event handler, I do 2 things. I change app variable points by +1 to increment it by 1. And then once that variable is changed, I then set the point label's text, which is the big label up here, to join together the string points and then the value of app variable points, so that it reads points and then whatever number I've accumulated. Down in the when subtract points button, click event handler, again I have a similar operation. For this button, I change app variable points by -1, which would decrement that value by 1. And then afterwards, I still do the same operation of setting the point label's text to join together the string points and the value of app variable points. And that's how this app currently functions. It doesn't have any functions defined in this app. Everything is all the functional code is just inside of my event handlers, but I could modify this app to include functions. And I want to show how you could modify it to include return functions. We saw a way of using void functions with this app last class, and now we're going to look at a way with it with return functions. So let's take a look at it. One thing that I might want to do to utilize a return function in this app is to build a function that updates the variable app variable points and then returns the string that should be put into the value for the point label. So my function's dual purpose here is to change the value of app variable points and then sort of set up and put together the text that should be in the points label after that change has occurred to the variable. And then that value, that string that should be put into the point label, is what this function will return. So let's take a look at how we might write that function. So my first step is going to be to grab out that to do something and return block from the function drawer. And then I'm going to go ahead and give my function a name. You can name your functions whatever you'd like. You don't necessarily also have to follow the camel case rules. You can choose whatever you would like. I chose to write my name in camel case just to make it clearer for me. And I also chose to name my function with a verb, with an action word. The reason why I've chosen to do that is because functions, like I mentioned, perform a task. And so if I'm trying to describe what this function does, it's probably best that I name it with a verb that explains what it does. So I've decided to name this function the create points label function. Create label text. Great. So that's what this function does. It creates the labels text. So then in my next step here, I'm going to now write my function. I want this function to do two things. The first is to update at variable points and either increment or decrement it, and then return the string value that should be placed into the points label. So in order to do that first step of either incrementing or decrementing the points at variable points value, I need to know whether it should be incremented or decremented. And so that's some additional information that the function needs in order to perform that task. And so when I have additional information that the function needs to do its task, that's an indicator that this function might require an input. So you can see that I've added an input to this function, and I've decided to call that input increment. That value is going to be either +1 or -1, depending on whether the add points button was clicked or the subtract point button was clicked. And then inside my function, I utilize that input variable increment to be the value by which at variable points is changed. So that's the first line in this function. Then down here in the return section, this is where I have placed the value that will be returned by this function. And I want to return the string that is going to be placed in the label. So I'm returning a string that is joined of the two pieces that are the string points : space and then the value of at variable points. So after this function executes, that value, that string points whatever, is going to be handed back to where I had called the function. So let's take a look at that. So now in the rest of my app, in my event handlers, you can see that the blocks inside the event handlers have changed slightly. What has happened is that the incrementing and decrementing of at variable points has been sort of relegated to the create label text function. And so those have been removed from the add points button and subtract points button event handlers. And they've been replaced with the function call for the create label text function. And you can see that the block to call the create label text function is shaped slightly differently than what we had seen with void functions. With void functions, the function call blocks had a little bit of like the triangle notch at the top here, whereas when you write a return function, they actually have the little notch on the left-hand side. And the reason for that is because this function returns a value, and then we have to then do something with that value. So in this case, the value that this function returns is the string that's supposed to go in the points label. And so what I've done is I have attached the function call block to the setter for the point labels text property. And this I'll give you another example of this in just a moment. You'll also notice that, like we had seen last class with inputs, that this function also requires an input, and that is looking the same way as we had seen before, where you can see in the function call block, it specifies that this function requires an input value called increment, and then I must provide some sort of value. For the add points button, that value is +1. For the subtract points button, that value is -1. So let's go ahead and run through this code together. So I'm going to start with the add points button. So when the add points button is clicked, I'm going to set the point labels text to, and then I'm going to call the create label text function. That function requires a value, and that value is an increment of whether I should change at variable points by +1 or -1 or even some other value, just some sort of numerical value. So for the add points button, I've decided to pass +1 because I want to increment the value by 1. And so then this function is going to get called with that value, positive 1. And so we're going to jump down to the function definition, and we're going to execute the blocks inside of it. So the first thing I'm going to do is change app variable points by the increment. So in this case, the increment is positive 1. So that means that app variable points will increase by 1. And then what I'm going to return is a string that combines the word points, colon space, and the new value for app variable points, which if this is the very beginning of the app would be 1 because we incremented from 0 to 1. So then what happens is that string, this join points, app variable points, this string that I've joined together and created, that string then gets handed back to where the function was called. So this is now back up in the add points button, click event handler. So it's almost like this function call equals that return value. It's almost like that they're the exact same thing. And so that string, if we go backwards, that string is what the point labels text gets set to. And then that's the entire run of what happens in that event handler. Similarly, with the subtract points button, I'm going to do a similar thing. So I'm going to set the point labels text to, and in order to set the point labels text, I need to first call the create label text function, and that function requires an input. So I've decided to pass the value -1 because that's how I want that value to change. So then I'm going to go down to my function definition and execute the blocks inside of it. So in this case, I'm going to change app variable points by my increment, which I passed was -1. And so app variable points is going to decrease by 1. And then again, I'm going to return a string that is joined together by the pieces points, colon space, and the value, the new value for app variable points, which could be -1, let's say. And so again, what happens here is that value, that string that I've created, that I've joined together, gets handed back to where the function was called. So again, it's almost like this block, this join block replaces the function call in a sort of way. And so then if we go backwards, we're actually going to take that string, and that is what the point labels text gets set to. And that is how this all functions. So calling the function, passing any necessary inputs, performing the operations inside the function, and then the function hands back some sort of result, some sort of value back to where the function was called. And here's a little bit of a walkthrough of how that works. So the event handler is triggered, and then we call the function passing the necessary input value. The function is then executed in order, and then returns the value back to where the function was called, and then that value is what the point labels text is set to. As I mentioned, another way that you might be able to visualize the way that this works is by actually taking that return value and sort of replacing it with the function call block. This will not call the function, and this won't have the correct functionality for the app. But this sort of gives you a visualization of what's going on when that return occurs. Again, that value is handed back as being sort of put back to where the function was originally called once the function is finished executing. Okay, and that is the basics of how a return function is built and utilized. The next topic I want to talk about is some more properties of sprites. We've talked about how sprites are a lot more interactive than your typical image in a Thunkable app. Because of that, they have a few properties that actually showcase that interactivity a bit more, and that we haven't gotten to talk about yet. So let's take a look at some of those. The first property I want to talk about is this one that's called is draggable. The is draggable property, its value is either true or false. And if its value is set to true, then the user or the player can click on the sprite either like with their mouse or with their finger and drag it around the screen using their finger or their mouse. So you can see in the example on the right, I have this little Funko beaver whose is draggable property is set to true. So when I test this app, I can click on or press on that sprite and then move it and drag it along the screen until I either pick up my finger or release my mouse button. If I had set the is draggable property to false, I wouldn't be able to do this. It would just, the sprite wouldn't be affected by me touching it or trying to drag it around the screen. Another unique property of sprites is a bounce property. The bounce property's value is an integer, and that integer can be anything that you would like, but that integer represents a percentage by which the sprite will bounce off of other sprites or the edges of the stage. So if you set a sprite's bounce property to 100, then that means that the sprite will bounce when it is touched by or it touches another sprite or the edge of the stage. And if it's set to 100, that means that the sprite will bounce at a continuous constant speed. So its speed will never slow down or speed up. Whatever speed it collided with the object with, it will continually have that speed. You could set a sprite's property to something smaller or larger than 100. If you, for instance, set a sprite's bounce property to 200, that means that every time it bounces off of either another sprite or off the edge of the stage, its speed would increase. It would double with every new bounce. In Thunkable, this can be a little crazy. If you give it a try in some of your other apps, you might see that the sprite will just start moving so fast that it just disappears from the screen. So that's something to keep in mind if you choose a value that's greater than 100, that if your sprite is bouncing a lot, it might eventually just bounce out of existence. But you can, if you want that kind of functionality, have the sprite bounce faster and faster every time it creates a new collision. On the other hand, you could choose a bounce value that is less than 100, all the way down to 0. And if you had 0, it wouldn't bounce at all, but you could go all the way down to 0. And if you had a bounce value that was less than 100, then every time the sprite bounces, again, either on another sprite or on the edge of the stage, its speed would decrement. So if, for instance, your bounce property was 50, it would become half as fast with every new bounce. So it would slow down over time. And you can see in my example, I have a sprite here that is both draggable and has a bounce property that's set to 100. So you can see in this little GIF, I'm clicking and dragging the sprite around and then kind of flinging it against one of the edges of the stage. And whatever speed it collided with the edge with is the speed that it sustains throughout the whole use of the app. So it'll continue to bounce at this speed for the entirety of the app. Okay, the next unique property of sprites I want to talk about is this one that's called passes through. So the passes through property, its value is either true or false. If its value is true, then that means that the sprite can pass through other sprites. So if it collides with another sprite, the other sprite is not affected in any way. It just goes right through, right over, right under the sprite. However, if the sprite's property is set to false, then that means that the sprite cannot pass through. No other sprite can pass through it. And so what will actually happen is it'll just move the sprite. This functionality only works if you have two sprites whose passes through property are both set to false. So moving the sprite around with another sprite will only work if both of their passes through properties are set to false, because neither one of them can be passed through. So in the example, you'll see I have this red beaver that I'm controlling with up, down, left, and right arrows. That sprite's passes through property is set to false. So this is saying that other sprites cannot pass through it. You can see the first thing that it does is it tries to pass through the dark blue beaver, and that sprite passes through property is set to true, meaning that other sprites can pass through it. And so you can see when the red sprite tries to collide with the blue beaver, it just goes right past it, and the blue beaver is unaffected. Whereas the teal or like greenish beaver, its passes through property is set to false, and so when the red sprite tries to collide with it, the red sprite actually just moves the teal sprite away because neither of them can pass through each other, so it's just going to move it as it goes along. The last property of sprites that I want to talk about is an angle. So all sprites always have an angle. By default, their angle is 0, which means that they're facing to the right on the screen. But your sprite can have an angle of anywhere between 0 and 360. The angle for a sprite is basically which direction the sprite is pointing in. It doesn't necessarily have anything to do with like how the image is. So with the default Thunkable beaver, the beaver does face to the right in order to sort of make the angle more obvious to the user. But if you had a different image, it might not be as obvious which angle it's facing. But you can choose which angle it faces. So if you have the angle set to 0, the sprite will face to the right. If it's set to 90, the sprite will face downwards. If it's set to 180, it'll face to the left, etc. If it was 360, it would go all the way back around to right again. And you can change it with anything in between in a in a clockwise motion. You can also set this property with getters and setters that are in the direction drawer under the canvas block section. If you would like. So you can set or change a sprite's angle using these blocks while the app is running if you don't want to have it set from the get-go in the designer. Another interesting thing about utilizing the angle property with a sprite is that you can actually set a sprite's angle to, instead of just a random number, a random angle, you can also set it to point towards another sprite. So if you want a sprite to like move towards some other one, then you can do that by using this block that says point a sprite towards another sprite. And so you can use that to have a sprite sort of face a different sprite. And lastly, along with using an angle, the angle could also be referred to the sprites as the sprite's pointing direction. So again, the angle and its pointing direction is just the way that the sprite is facing. If it started to move, the direction in which it would move. So you could use this block, set a sprite's speed to a value in a pointing direction, to instead of having the sprite just move along the X or the Y axis, which is what we had looked at in a previous class, you could have a sprite move towards its pointing direction, so whatever angle it's facing, which gives you a little bit of an easier way to let the sprite move in the direction that you want. And that is all the sprite properties that I wanted to talk about. We're going to utilize those sprite properties as well as some return functions in building the Bouncing Ball app, which is the in-class app that goes along with this lecture. So go ahead and find the second video where I will show you how to build this app.